Hello, everyone, and welcome to our latest webinar, Cost Optimization Strategies for IT Leaders in 2023, with BigPanda's Jason Walker, Chief Technology Officer, and Connor Castronovo, Senior Analyst Relations Manager. Now, before we get started, just a few housekeeping items for our audience today. You have a couple of ways to enjoy today's session by using your computer speakers or by phone. If you'd like to listen in using your phone, just select phone call and dial in. Our session is being recorded and you will receive a replay link in the next few days following today's broadcast, as well as this broadcast being available on the BigPanda website. And of course, we want to hear from you, our audience. Chat with us using the Q&A widget, and we will get to as many questions as possible. And without further ado, let's head on over to the BigPanda studios. Go ahead, Connor.
Great. Thank you so much, Maria, for the introduction. And thank you all for being here today to learn how organizations, just like yourself, can optimize their costs through AIOps. So before we jump into everything here, from a validation standpoint, BigPanda has hundreds and hundreds of organizations, and we know where their data comes from and where they struggle. So we have a decent slice of the operations world, so we know where a lot of that waste is coming from and where the inefficiency is out there. Some organizations are caught up more so in the administration aspect. So we will dive into some best practices and how you can get the most value out of your NOC team. As we jump forward here, the four main areas that we want to focus on today would be number one, spend. Number two, scale down collaboration systems or OpEx. Number three, opportunity costs. And last but not least, standardizations and processes that you can take with you and leverage in your own organization. Many of you may be asking, what is cost optimization? So before we get into details on how AIOps can assist in your cost optimization efforts, let's understand what are industry trends and industry definitions of cost optimization. So Gartner defines cost optimization as a business-focused continuous discipline to drive spending and cost reduction while maximizing business value. So this includes obtaining the best pricing when you're going through business purchasing, standardizing, simplifying, and rationalizing business operations and applications, and automation, automizing and digitizing IT and business operations. So again, you can get the best terms in pricing. And as we jump forward, we will now dive into cost optimization using AIOps. Some key takeaways here that we've understand are from EMA. EMA report has showed us that the average cost of an outage is now at $25,402 per minute for organizations with over 20,000 employees. So most organizations view their NOC center or network operations center and its annual budget as an internal and external IT service. But as you all know, in reality, this is just a starting point. There are many other hidden costs that come into the ridiculous amounts that ITOps can experience if they're poorly managed. So normally small operation centers run all the monitoring and incident management workflows, which uncover every service an organization runs on. And this means your ops team needs to be there to detect and respond to any issues as soon as possible. And their ability to do so is dependent on the coverage and the quality of their monitoring sources. So when this noise is overwhelming and coverage isn't there, a service failure can ultimately go undetected for minutes, hours, days, or even weeks, resulting in wasted money, time, and resources. Going back to this EMA poll. So EMA polled 300 plus IT leaders to create this up-to-date actionable stat. And the average cost that we've noticed across all these data points is $12,900 per minute. But as I said before, the larger the organization, the more expensive an outage costs. This means the more potential revenue at risk. And that doesn't mean smaller companies are in the clear, because these smaller companies normally lack the resources to recover efficiently from hits to their corporate health, such as an outage. As we jump right along, there are three main pricing models that you can use in the AIOps space especially from a cost optimization standpoint. So the size and usage normally differs depending on the advantages or disadvantages that your company is looking for. But the three main pricing models are consumption model pricing, number one, and this is credits consumed by platform usage. So you can start small, grow over time, but the challenge is you can run out of credits. But overall, the pros here are easy to measure, it's flexible, only pay for what you use, and but it is hard to predict and hard to identify some core values there. Number two is subscription pricing. This is normally a monthly or annual subscription, and the customer benefits from this are it's predictable. So it's easy for your finance team to track, but the challenge is you need to renew every year or month, whatever your service is, and you could pay too much upfront and can experience some customer churn. And last is perpetual pricing. This is a one-time fee that customers can hold indefinitely. So the customer benefits are immediate, rapid time to value, and everything's in one place. It's easy to track, but the challenge is lacks pricing flexibility. Jason, quick question for you on this. How does an organization optimize its costs and deal with the ITOps tax?
The ITOps tax, I mean, when it comes to pricing models, I think you really need to figure out where you are in the maturity cycle for whatever you're buying, whether it's an observability solution, an AIOps solution, an ITSM, or a paging system or something like that. If you're low volume, small team, you're in DevOps, a consumption model might work for you, especially if you have very good controls and visibility. And that's really the risk around consumption models. Subscription, you want to go with a firmer understanding what the metrics that are driving the subscription price. If you're measuring nodes, for instance, you want to know how many nodes you have and how many you need, and you want to obviously right size to that amount and to negotiate a pretty low unit cost. And then a perpetual license, really you see that with bigger enterprises. If they want to lock in their costs, which finance departments often do, that sometimes if you don't know how much you're going to use, or if you're in the midst of some digital transformation, some larger initiative to expand the usage of a given operations tool, then a perpetual license could give you a way to fix those costs. And a lot of people do that around like a cloud solution. They'll go in with GCP or AWS and do a long-term commit for a certain amount of spend, but buy it over a period of years. And perpetual is perpetual in name only. It's not actually infinite. You don't lock in today's prices forever.
Great. No, I appreciate that. And as we move forward too, Jason, I know you'll dive deeper into some scaled down collaboration systems here, such as OpEx. So with that being said, I will kick it over to you, Jason.
Yeah, absolutely. I think cost optimization is more than just a finance exercise and a contracting exercise. You really need to look at all of the costs within an organization when it comes to ops, and most of them are invisible. It actually took a long time to build this particular graphic, just putting together the data over a period of months with an organization and then running it through a pretty rigorous analysis. That tax, that long-term cost of what is it costing us to run our services, from the infrastructure, network, cloud, application tiers, the development, and all of the running costs, all the effort that all of the engineers, all of the operators, L1, L2, L3 have to put in to actually keep those running. Well, if it's a very failure-prone system, you would say, yeah, that's going to cost us more because we're always having to run incidents and figure out what's broken and get it back online. If it's not a very failure-prone, it's a very reliable, high-available system, then obviously that's going to be less costly. But most organizations don't measure the difference. And so you can have two different services within the same organization that are massively different in terms of the amount of human spend, the time and effort required to keep them running, and nobody really knows. So we tried to put together a picture of what most organizations look like across most of their services. And that really starts here. If you take it from the left, obviously you got a timeline along the top. And time is very important when measuring cost. Obviously, time is money. But we trace the life cycle of events from their source systems all the way through to when the issues were resolved. And every one of them went through a pretty similar set of patterns. First of all, a lot of the OpEx spend that you have on monitoring, it immediately gets black holed into that native dedupe and filtering that most organizations will have. They'll just get rid of a lot of things that they know are non-actionable noise right out of the gate. And in this case, 3.7 million out of a total of about 5.5, 6 million. That's pretty massive. If you can right size some of that monitoring spend, then you'll save a lot of money. The rest of it turns into tickets, and those tickets, 1.8 million, are often looked at as incidents, but most of them are not true incidents. They don't represent a service outage or degradation. They all go through a similar process, and it happens in phases. The first phase is that initial assignment. So the ticket will either get routed to maybe directly to an SRE, a DevOps, a domain-specific engineer, or to an L1 team like a NOC. And you see that in the pink going up to L2, L3, or down to L1. Once it hits that team, it goes in one of three directions. The top path is the happy path. You can see in the kind of light brown, immediate remediation by L2, L3. Yeah, that's a fairly large chunk. And then the rest of them, and this was a historical analysis, the NOC ran a run book and was able to remediate the issue right then and there. Now, the rest of those tickets either were identified to be noise. Hey, this is a transient condition, and that's on the very bottom. And that's kind of the second best case scenario, because at least you're getting rid of that ticket at that phase. A lot of the L2, L3 went down to manual noise filtering there on the bottom. And a large proportion of what hit the NOC also got filtered by humans. And that's just closing the ticket without any action. Now, the rest of them, they went to the light green. And that is the second assignment. Hey, I don't know what to do with this. I can't tell what's wrong, what is happening here, or if it's something that we need to action. So I'm going to pass it to somebody else. And that's when your cost starts to accrue. And also, if you're talking about an outage, you're now in the minutes to hours time frame. So you've been down for a while and you don't really know what to do. And then the whole decision cycle repeats itself. Can I remediate it? Do I have the knowledge I need, the information maybe from my change systems, topology systems, my monitoring systems? Do I a run book, that sort of thing? Can I remediate it now? Or can I classify it as noise? Hey, I know enough about this to say it's non-actionable, and that's the bottom path again. Or do I need to assign it yet again to a third resource? And that repeats itself. Some of it gets remediated, some of it gets filtered manually, and some of it goes to a fourth assignment, and then a fifth assignment. And, I think the record's around 17 assignments that we saw, but I didn't want to extend the graphic that far. But if you think about that, you're now into the days and weeks category. And this ticket, this ITSM ticket, has been bouncing around the organization, consuming a little bit of people's time. Maybe it's 5 minutes, maybe it's an hour of research, until it finds someone who knows enough to either close it as noise or action it and get rid of it. But people aren't necessarily inclined to say, hey, I'm gonna deal with this myself, if they don't know what's going on. And you get into a lot of problems with tribal knowledge there. And so this is incredibly expensive. If you measure all of the FTE time involved in a ticket that bounces 5, 6, 7 times, or even 2 or 3 times, it's really what happens in organizations is they'll add a second or a third live ops resource to a team, an engineering team, a DevOps team, because this workload gets distributed across everybody. This will be, my old company, we had 1,200 engineers on call, and they would get tickets, and that would just be part of their day. But nobody's ever actually measuring how much time they spend doing that. And so this obviously is ripe for cost optimization.
Great. And then the next few slides we have here kind of dive deeper into those areas of optimization that you were talking about.
Yep.
So as we build this out here, as you were saying, time in seconds, I can pass it over to you again, Jason. I'm sorry if I cut you off there.
Oh, no, it's okay. This is kind of the post-AI ops world, and same organization, same sources, same source events. But in this case, you're really doing a professional job around deduplication, filtering, and suppression. You're taking care of a lot of that noise right out of the gate. So all of those things that were classified as manual noise filtering in the previous graphic, we're now catching those before a human ever looks at them. And I just like, people don't realize how much time that takes. I want to emphasize and let that sink in. You catch it because you bring all of your topology, your change data, your maintenance data, your third-party services that are running maintenance, that maybe it's an ISP out there, and you get a maintenance notification. Well, the alerts that fired in association in your systems that were associated with that ISP, you're now suppressing those. And that's just because you put the two pieces of data together that were necessary to determine, hey, this is non-actionable noise. We know this ISP is down for maintenance. We're not going to send that alert on to you. You're already routing traffic to those customers through some other path. And that cycle kind of repeats itself across all of the maintenance events. And everybody has second and third party services that they rely on now, that they're doing work all the time, just like, you know, any large scale digital service, you have to maintain it. So that first red bar of deduplication, filtering, and suppression, it's massive. It's 5.5 million. And then you get down to the actual incidents from there. So with the right knowledge about change and topology and service ownership and on-call resources and correlation of related alerts. Hey, all these alerts are related to the same incident. The same root cause had maybe a causal alert. This system or subcomponent is failing, and these other ones are firing symptomatic alerts because they're no longer getting what they need to function properly. That's all correlated together into one incident, because you can see there's multiple observability systems here. They have no knowledge of one another, so a single failure can cause a cascade of alerts through multiple systems. So when you correlate alerts like that, you get what we call a correlated incident in AIOps. And that gives you a very rich set of information around what's going on, because you have multiple observability sources looking at that. You also get the most recent changes that are in proximity to those alerts, and any other activity that you might see in proximity to that. So you get this very nice package, and what that allows an AIOps solution to do is route it properly. So it doesn't bounce around, get reassigned. One person looks at it, decides they know enough about it to act on it, or they don't, and then they pass it on, guessing who is going to be the appropriate person to look at it. Now you can automate all that. And so it goes directly to, in seconds, again, one of these spaces for the teams. And then you automate the ticket creation and all of the notes and human investigation that goes on to classify an incident. Where is it occurring? What service is involved? What team is involved? What applications are involved? What infrastructure, maybe? What network devices? What are the third-party dependencies? All these things have to go to various knowledge systems to look up and put into that ticket. Well, if you automate all that, instead of taking minutes or hours, that takes seconds, and it's done 100% consistently. And so that then routes those tickets to the right person. And that's where you see the ServiceNow, xMatters, and ServiceNow. Those are the systems that AIOps automated the delivery to them and the assignment of those tickets to the appropriate on-call resource or like dedicated NOC operator. And you still, I mean, there's still a lot of situations, those non-action environments at the top there. That's noise that survived, and somebody's going to have to take a look at that, but they're grouped into something called non-action environments. So that's on a low priority basis that people spend time looking at those, but it's a far lower number. If you remember back to that previous graphic, 1.8 million tickets created, we're already down to 45,000. So that's a pretty big step function in terms of efficiency.
Definitely. I would say so myself. And as we jump into some of the opportunity cost that comes with having a slow working NOC or a messy NOC, as we say, we ask ourselves, why are we doing this, and why are we doing this now? So with that being said, Jason, how would you highlight each of these areas on screen here?
It's always interesting when you look at an organization and look at all the incidents they have to deal with, and all the phases, all the process phases they go through. You have detection, investigation, remediation, triage, response here. The speed with which you do that is largely dependent on your input and output from your knowledge management systems or whatever tribal knowledge you have stored upstairs as an individual operator. And most organizations are on some sort of round robin. An alert comes in, it goes to the next person in the queue in that frontline response. Sometimes, DevOps, SRE, they'll direct the right alerts to the right person that knows that system. But those manual workflows, the manual incident detection, the searching through a logs stream to actually investigate and diagnose an issue, all of that costs, like we talked about earlier, a whole lot of people, or a little bit of time. So a whole lot of people, a little bit of time each time it happens. And when you're talking about millions of events, millions of alerts coming into an organization, you don't do that just one day when a major outage occurs. You do it every day. And you have entire teams dedicated to doing that. And you have little portions of everyone's time. And so when you're manually working these tickets through a system, I call it ticket jockeying. You're just kind of passing around the workload until it arrives at the right person who has the right knowledge to deal with that incident, either close it out or fix whatever's broken. And that's just incredibly costly. And like I said, you will add people over time to absorb that work, but you're not measuring the work itself. And so those manual processes, without the benefit of the right data at the right time with the right context to deliver that nice package to that operations individual, whether it's DevOps, SRE, NOC, or a domain specific engineer, they're going to take time and effort to run through these stages. They're going to do them probably very consistently, but 1.8 million tickets, if you're 95% successful, there's still tens of thousands of tickets that are handled very, very badly. And that could be outage time, or it could just simply be inefficiency. And so these manual workflows, the slide title is a little pithy, but they really do prevent a better tomorrow. There's a better way now.
Great. No, you touched on that perfectly, and especially addressing some of those issues with, historically the industry has mentally defaulted to automation and auto remediation. So I definitely agree with you there. And as we move forward to our next section here, we have it titled as AI Ops is the cornerstone to automation strategy. So the way that I look at this is AI ops and automation boost efficiencies and ultimately can reduce the business impact of outages, as you discussed on some previous slides. So this ultimately results in greater time savings across diverse teams and gives the enterprise the time back for new digital initiatives. So my question I have for you then, Jason, would be, what happens if a scenario gets messy here as well, especially after a customer-facing service has that existing issue already?
When you fail to automate and you're not putting the right information in the right time, you can really, at the very, very worst, you'll have detection issues. And I've seen organizations that are entirely reliant on human reporting. You might have, if you don't have good observability, you don't have a good way to use your observability. Maybe you have those logs, metrics, traces, and alerts coming in, but nobody is really in place to receive them. You don't have that centralized strategy to be alert driven. That could fall on your customer service department. And it could rely on a human, actually, one of your customers calling in and say, hey, when I press the buy button, nothing happens. And then now the clock starts ticking. And how many purchases don't go through? How long does that problem exist before it actually gets addressed? And then, internally, you blow up your customer service organization to absorb all of that. Now, better run, you're alert driven, you're centralized, and you're generating those tickets. Yes, you have a centralized strategy. You're passing those tickets out to everybody every team to triage, diagnose, and remediate those or classify them as noise. That's better, but it's still incredibly costly. And critically, those engineers are not working on projects when they're working on incidents. And that's really the huge opportunity cost there. Now, when you start to automate things, like I showed you in the ITOps model, the association of maintenance events with alerts to suppress those alerts that are associated with known maintenance, the correlation of different alerts so that it can be diagnosed much more rapidly, the contextualization of alerts so that whoever receives them has kind of the full package, it knows what's going on. Now you're starting to really reduce the time to action, and you're ensuring that everything that hits humans is actionable. And so you start to claw back development time, engineering time. And what you see there when organizations really embrace automation in the operational workflow is their projects move faster, development velocity increases. And that's such a huge payback because every business is fully digital, fully online these days. Everything is IT. And if you can grow your services, your capabilities, make them run cheaper, more efficiently, all of that will help you run a better business. And that's where CFOs start to pay attention to what CTOs and CIOs say is, hey, I can give you back 20%, let alone the customer service department, which if you prevent incidents from ever impacting customers because you're catching them really early in the cycle, you don't need as many people responding to customer calls. And so that I've seen that be an 8-figure reduction in cost because it's just such a massive impact when you have unhappy customers. That is very costly and very net.
Definitely. No, wow. That leads us right into our next section here of some outcomes of automating IT operations. So from a full-time employee or FTE component, scaling through AIOps ultimately allows you to be more operationally efficient because, as you know, Jason, a fully realized FTE is tremendous costs. And I'm not saying, hey, let's go ahead and get rid of engineers, but rather let's use them as strategically as we possibly can. So being able to repurpose some of these engineers so they can focus on more business critical impacting activities, such as digital transformation or any critical digital innovation, will result in more revenue than just being on call waiting for something bad to happen. So cost optimization to me, then, it starts with doing more with less. By driving less degradation results in more uptime, which equals more revenue. So this is what CIOs sometimes are commonly metriced on as well. So an example of extending the value of an existing tool through tool optimization, and you can scale intelligently. So in your experience, Jason, what does suboptimal IT ops look like in practice?
In practice, what you see is across every team that touches those services, you have slightly more heads. You have a few more engineers, you have a few more PMs, you have a few more folks that are working on live ops issues all the time. And it really is a creeping and increasing cost because as these services age, they get more expensive. It's just like, a vehicle. Eventually it starts to break down more and more. And so you add additional headcount. And I want to, most businesses today, and the ones I've been a part of, headcount represents at least half, sometimes 95% of your overall budget. If you're a fully digital service, you don't have a large manufacturing component or you're not buying raw materials, which is a choice few industries at this stage. And most of your business is digital services. Your costs are almost entirely headcount. And so when you're running inefficient ops, you have excess headcount that you are not counting the work that you're getting out of them when it comes to operational needs. And once you implement a solution that can measure how much effort's going in, all of a sudden you get this great insight on, oh wow, I have these engineers in place because I have these live operations problems that need to be dealt with routinely and repeatedly forever and ever. And that then drives some decision making around how you architect your services, how you monitor them, and how you respond to any incidents, and what strategy you pursue there.
Great. No, that's great insight. As our next slides come up here, let's get a little bit more tactical. You know, what is one thing that you can do today that is very straightforward to reduce cost is we can kind of tackle some of the big ones. So, Jason, in your experience, you know, what is the main issue when an individual runs into a low quality alert, medium quality alert, high quality alert? And how do those vary in the amount of time that it takes to action on one of these?
You know, I'll start with the high quality because that's kind of the happy path. And this is definitely possible with standards like OpenTelemetry coming in, and a really robust analysis of alert actionability over time. You can get high quality alerts. It's very, very possible. And that's an alert that's fully contextualized. It's got all the information that you need to know in order to action it. Hey, this is broken. This is where it's occurring. Here's everything we know about that from your topology systems. Here's all the changes that occurred in proximity. Here's maybe a run book or even a remediation script, or a payload for a remediation system. That high quality alert comes in and it is instantly actionable and goes to the right person with the right priority to get handled within SLA or within a timely manner. And that's very, very possible today. Now, medium quality and low quality, that's really a failure of the organization to address alerts as really they lack a strategy to deal with monitoring. And what we see over and over again, in my experience, has been the longer the monitoring has been around and the service has been around, and often services persist for years. If you think of AWS's website or Amazon.com, that website is over a decade old, 2 decades actually, and there are probably still some of the original alerts in there that were configured during the development and left on because it is there's an agency problem. If I'm a new engineer on a service, I don't want to turn off the old alerts because someone else made the decision to monitor whatever that is. They considered it important. And I'm really not in a position as the new engineer on the team to say, yeah, just go ahead and ignore those. Because if you're wrong, the service goes down and somebody says, well, shouldn't we have known about this? And maybe the old alerting would have caught it. That's the mindset that they're in. And if they're right and they turn off the alert and there's slightly less noise, that's not measured. And so there's a cost benefit analysis that goes on for anybody who looks at alerting. And the default position is always, yeah, leave it on, keep processing it. And then you look at a service after maybe 20 years, 25 years. And what we see over and over again, 99.7% of those alerts are useless and no one is paying attention to them. They come in, people create tickets around them, and then those tickets are closed in bulk. Often they automate that process and they catch it a step too late. But that's really because they have no mechanism to guard alert quality, to properly normalize, ensure the payload has all of the required attributes, and that it's actionable. And so there's just a very basic strategy you can put in place around monitoring quality that will immediately yield benefits. Hey, if you just look historically, this alert has fired 6,000 times in the past 2 months. We have never actioned one of those. Have the intestinal fortitude to go ahead and turn that alert off. That's what it takes, is somebody to say, hey, this is a broken system and I'm going to start fixing it. And then you start to get better. And after the first one, it gets easier to turn off the next one and the next one, because really an organization that is experiencing 200,000 incidents per month. I've heard that. 200,000 incidents per month. You're running a pretty small scale service. Is it always down? no, it's mostly up. This is how they reply. No, it runs pretty well actually, but you're running 200,000 incidents around it, and you have a team of 1,000 people that are investigating each of those incidents. How many of those are you actioning? Oh, only like 5 to 10 per week or per day. So how are you running 200,000 incidents? People have let go of the reality of what an incident is. It's a service degradation or an outage or the indication of one. And that's what an alert is supposed to detect. And when you let go of that and say, no, I need to just process alerts, I need to process more of them faster, and you let go of quality, then you process noise very quickly at great cost to your organization, and it accumulates over time. And if it were on if it was in some sort of manufacturing plant, you would see the buildup and the accrual of material there as alerts went through. But in the digital world, it's invisible and unmeasured. And so it's just allowed to persist over years. And yeah, people get used to it. They normalize to it behavior-wise. And then nobody measures the cost of it until the business is just running so inefficiently that change is required. So yeah, that's fairly tactical, a little bit strategic.
Great. No, very, very, very insightful. And that leads us right into our next section here around how an organization actually standardized it in the real world, put this into practice. And the organization we'll be focusing on here is Sony Interactive Entertainment. They actually standardized the approach to this problem and did it across the whole entire organization. So now they don't ingest an alert unless it's actionable and prevents bad alerts from entering the system. So as I said, Sony is eliminating any non-actionable alerts, reducing the number of total alerts, which reduces cost and time. This plays a factor into certain operating costs. So this benefits everyone from the CFO to budgeting to focus on more strategic initiatives that they have to focus on. Because once you have an actionable alert, you no longer have to spend a second of full-time employee time actioning on those non-actionable alerts, and you can get those hours back. So as you can see here, one thing that I really, really liked was Priscillano Flores, the staff software systems engineer at SIE, said, "We are seeing fewer outages using alert standardization because our NOC can now truly get ahead of them." And with that, they saw a different attitude within the operation system, and they weren't getting woken up in the middle of the night for something that wasn't really an issue. And Jason, I know in your experience, you've been on many of those late night bridge calls or firefights that are unexpected. So
yeah, and there's nothing more demoralizing or that really causes a lack of trust in your operations team than escalating, notifying somebody, waking them up in the middle of the night saying, "Hey, I got an alert that said this. I need you to look at it." And the engineer takes one look at it and says, this is nothing. This is a transient condition, happens all the time. Why did you wake me up? Repeat that process 1,500 times a week. All of a sudden, the engineers no longer trust the operations team. They stop responding to pages. They stop actually believing, and then they start doing their own monitoring, kind of black ops style, which I'm sure Sony Interactive Entertainment's familiar with. But they start to run their own operations in chat or something else, and they're spending a lot of time really bypassing the operations team because they can no longer trust them. What Priscillano saw was that different attitude that he talks about. Hey, I'm never going to wake you up if I don't have to. And that's a promise I think operations team want to make to the thousands of engineers that are on call, that they feel a huge responsibility to not wake people up in the middle of the night. If it's a P1 or P2 issue, though, they have to. And that's where alert quality and standardizing it, you really need to have high quality alerts, because that is the cost to your engineers. And the next day, after you get woken up in the middle of the night for something that was useless, and you're up half the night trying to diagnose it and figure out what it might be, you're not as effective the next day. You're not working on that project with the same intensity. It's really costly to not invest in this. And that's It's hard to measure, and I think that's why it's gone on for so long. But it absolutely has a very human and a financial toll on organizations.
That's awesome. No, really appreciate that individual experiences as well. The main three takeaways, especially that I've really understood from today, would be number one, you got to get your contracting right. Whatever solutions you're using in the AI ops space, make sure that you're getting the pricing model in line with what you need. And then number two, run a good operation so we can avoid being woken up in the middle of the night. Set yourself up to run an efficient system. Half the job, is just showing up. And number three, good tactics. There are systems in place that are insufficient. There are issues that you may run into, but setting up a good system, you can avoid that. You can do it once as an organization, and you don't need to invest anything else. So you can stop wasting time in something that you can do tomorrow and avoid consistent alerts that you can avoid over time, and get that time to invest in some mission critical priorities there. And is there anything else that you want to add, Jason?
I would just say, the golden rule in most, IT decision making: measure what you care about. I would make sure you're measuring whatever solutions you get. Make sure you measure their effectiveness, and that's part of getting your contracting right. Running a good operation, define what that means to you, and it probably means something along service availability and then efficiency. And so measure both of those things. Organizations do a great job of service availability. Efficiency, how many of our alerts are actionable? How much time are we actually spending? They don't do a great job there. And then good tactics. I mean, that kind of goes without saying. You gotta bring your A game when it comes to ops. Digital services, all of your online systems, your employees' time. That is very costly when it runs bad. And no one is going to die, immediately if one of your systems is down, especially Sony Interactive Entertainment. PlayStation's a great service. Millions of people love it, but it's not life or death. But I would say for the business, it really is. And what they've built over there using AI ops principles and systems, they've now made that a strategic advantage. And that I think, they have good tactics, good strategy, both there at Sony.
Great. Well, Jason, really appreciate the time today. Thank you, everybody, for coming out. And I look forward to our next conversation.
All right. Thanks, Connor. Good talking to you.
Thank you, Jason and Connor. Great session. We want to thank everyone who joined us today. Learn more about the BigPanda platform and how we can help deliver domain-agnostic AI ops and get the insights you need as you continue working through 2023. See how BigPanda works for yourself with our self-guided demo. And finally, explore stories about our amazing customers. And of course, when you're ready to meet with the team, give us a shout at bigpanda.io. And with that, I'd like to thank Jason and Connor again, and we look forward to seeing you soon. Thank you and goodbye.